This lesson is properties of squares, and so a square is another parallelogram with some additional properties. So it has 4 congruent sides, and it also has 4 right angles. So we're going to use those properties to find the measures of sides, diagonals, and other angles. So let's go down to their picture, better than one I can draw. And we have the properties of squares. So first, if we fill this in, it has the first 5 properties that are true of every parallelogram. Opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. And diagonals bisect each other. Okay, so those are true of every parallelogram, but now we have 2 additional properties that we added for rectangles. It has 4 right angles, and diagonals are congruent. But then it also adds the next 3 properties that we added for a rhombus. It has 4 congruent sides. Diagonals are perpendicular. And diagonals bisect opposite angles. So let's look at the picture here and see what that means. Okay, the most important things are going to be, okay, these are all perpendicular, as with the rhombus, and all the sides are congruent. The diagonals are congruent. Okay, so what we end up having is, let's look here. We end up with these 4 congruent triangles. Okay, inside the square, we have these 4 congruent triangles that are right triangles, and all the sides are congruent. And then we use a different color here. All of these are congruent. So what we end up with, let me draw up here. We end up with 45, 45, 90 triangles, which have the properties of x, x, and x to the square root of 2. So hopefully you can go back to that and recognize. And so this is a 45, 45, 90 triangle because the diagonals, the angles are 90, but the diagonals bisect the angles. So these are all 45. Okay, so we have a 45, 45, 90 triangle here. So we have 4 of those, but then also look here. If we break this down into just 2 triangles, we also have 45, 45, 90 triangles. But now, here's the 90 degrees. And so in the green triangle, across from 90, or this whole diagonal, would be your x to the square root of 2. So let's try and break it down into some of the examples and look at the individual examples. But hopefully you can see we have all these 45, 45, 90 triangles where you're going to have to apply the properties of the 45, 45, 90 triangle. Okay. So example 1. Let's see. We have a square. So again, these are 90. These are all 45. Okay. And MA is 8. So this side is 8. Well, it's a square, so all the sides are the same. So if one side's 8, they're all 8, so AT is 8. Then it asks about HST. Let's see. ST is right here, and those are all 90. Then it asks about MAT. MAT is right here, and again, all of those are 90. Then it tells us that HS is 2. Change colors again. HS is right here, and it tells us that that is 2. Remember, this is a midpoint, and all of these are the same. So if that's 2, we have 2, 2, and 2. And then it asks for HA, this entire length. So 2 plus 2 is 4. And MT, and that will also be 4. All right, let's go to the next example. AED. So AED is right here. And again, all of these are right angles. So 5x plus 5 equals 90. So 5x is equal to 85. If we divide by 5, I think 17, but let me double check. 85 divided by 5 is 17. Then part B, ABC. So where's ABC? It's right here. And again, those are 90. So 91 divided by 13 is 7. Okay, so in all these, the squares have the most properties, and so you need to carefully look at what they give you and try and break it down for the picture. So in example 3, BAC. So where is BAC? Okay, BAC is right here. And so here, remember, these are always 45. So BAC, 7x plus 10 is equal to 45. Subtract 10 and divide by 7. So x is 5. Always double check my arithmetic in my videos, or I try. Okay, CDB. CDB is right here. And again, these are always 45. So just 5x equals 45. And so x is going to be 9. Okay, let's look at example 4. And I can see that we're going to use our 45, 45, 90 triangles. Okay, DB. So this entire length is 9 to the square root of 2. So what we're looking at is this triangle right here. This is a 90-degree angle. The sides are the same. So this is x, x, and this side is x to the square root of 2. Okay, if you want to draw it separately, that might be helpful. The side across from 90 is x to the square root of 2, x, and x. And the measurement that they give us is that x to the square root of 2 is equal to 9 to the square root of 2. So that makes x 9. So they're asking for BC, which is one side. All the sides are the same. And so all of the sides here are 9. All right, so then in the quick check, let me erase and just a little bit. Okay, and this one here, we're going to want to break it down because they give us this measurement. So here we're going to break it down to the smaller triangles where this is 90 and this is 45, 45, 90. So across from 45 is 13. So draw it separately, we have x, x, x to the square root of 2, and the measurement that they give us is one of these, is 13. So they're asking for a D, which is right here, which is a side across from 90. Well, if this side is 13, this side is 13 times the square root of 2. So that is across from 90. Okay, the squares have the most properties, and so there's a lot of possibilities here, and this one, it can get a little confusing. So please do your best on the practice, and later today, I will upload the answers to the practice so that you can look and compare, and I'll try and work out the steps for you. All right, good luck.